Hello students, this is lesson U1A06A. Hopefully by the end of the period, you should be able to say I can solve angle relationships formed between parallel lines and transversals. And in particular, we are going to be working with alternate interior, exterior, and corresponding angles. So I want to remind you that the fifth axiom of geometry, remember the five pillars, okay, that make up this course, remember that from the very beginning, from one of the earlier lessons of this year, right? So two lines, okay, that are parallel will never ever meet. That was one of the truths, okay, that one of the statements that we accept as true and that we do not question, okay? Two lines that are parallel will never ever meet. Well, there's a scenario here that I want to present to you. So suppose I say, okay, suppose I give you that these two lines that are in blue are parallel, right? Those are parallel lines. We can call those parallel lines. And then I give you another line now, which clearly is not parallel to either one of those parallel lines. However, it cuts right through it. There's a name for this line, okay? And the name for this line is referred to as a transversal. Okay? A line that cuts through two given lines is referred to as a transversal. And in this case, it's cutting through two parallel lines. All right, so what does that mean? Well, there are a lot of really interesting things, okay, that can come about this, okay? So let's take a look at what I mean by that. So what I want you to do is suppose I give you, okay, angles A and B, okay, which are these two angles here. They, okay, must be the same as which other angles? I want you to pause the video for a moment, okay, and I want you to label all these other places, okay, either with letters A or with B, okay? Go. All right, so welcome back. If you think, okay, that this is angle A, you're absolutely right because that is a vertical angle. That angle there will also equal angle A. If you think that this is angle B, that you're absolutely right about that as well. However, this is the part where you need to make an intellectual leap, okay, where this idea of a parallel line where the two lines will never ever meet, okay, what will happen is with the transversal, we are going to reconstruct the same number of angle measures, okay, the same kinds of angle measures here. So for instance, okay, this angle over here will also be congruent to B. This angle over here will also be congruent to A, and so on and so forth. So there's a name for all of this so that we can all communicate. All right. So this right here is what we refer to as corresponding angles. Okay. And there are actually four different sets of corresponding angles. So you see how this angle over here, it corresponds with this particular location? Yeah, hence corresponding angles. And do you see how this angle A here corresponds with this angle A over here? It's in the same quote-unquote location. Yeah, hence corresponding angles. And once again, this angle B corresponds with that angle B because it's in the same corresponding location, corresponding angles. And one more time, this angle B corresponds with that angle B. And again, hence corresponding angles. We refer to this, okay, this angle over here, it doesn't correspond with this angle over here. What there's a name for that. This is called, because this angle B, they're on opposite sides of that transversal, we refer to this as alternating, okay? To alternate something means to go on like one after the other, right? So we're on either side, okay, of that transversal. Why is it alternate interior? Well, that's because angle B right now, it's in between the pair of parallel lines, which is why we're calling this an alternate interior angle. So alternate interior angles are going to be congruent. How many pairs of alternate interior angles are there in total? Well, we also have this side, right, which are alternate interior. So therefore, angle A and angle A over there are also congruent, okay? These are alternate interior. And again, one more time. So these are alternate interior, alternate interior. These are what we call alternate exterior. Why are they exterior, you may ask? Well, that's because these two angles are not in between the two parallel lines, but they are outside of the two parallel lines. Hence, we call this exterior. And they're alternating because they're on either side of the transversal. So we have alternate exterior angles here. And how many pairs of alternate exterior angles are there? There are actually 2 pairs of alternate exterior angles. All right. So in summary, ladies and gentlemen, here are all the different angles, okay, that you need to be familiar with. We have corresponding angles, we have alternate exterior angles, and then we have alternate interior angles are congruent. Let's try to apply these concepts in these problems here. Let's take a moment, okay, pause and think about how you're going to be able to find all the different angles formed by the transversal and a pair of parallel lines. Oh, and by the way, I didn't mention this during the introduction. This symbol right here, you see the arrowhead, which is not at the end of the line, but it's somewhere in between, like in the middle of that line. Well, those arrowheads, okay, indicate parallelism, okay? So if you see those arrowheads pointing in the same direction, that is an indication that those lines, L1 and L2, are parallel, okay? This is to affirm that what you're observing there is actually accurate. If diagrams do not have that, and if there's no mentioning that the two lines that appear to be parallel are indeed parallel, you cannot assume that lines are in fact parallel, okay? So it needs to tell you, the problem statement itself needs to indicate to you that the lines are in fact parallel, which in this case the diagram is doing that. All right, so let's take a look. So hopefully you paused the video and now you're coming back to it, okay? Now let's take a look. You have this angle here that's given, and you have this angle here that's given, although the exact value of those angles are not given to you. But what kind of angles are they? Are they alternate interior, alternate exterior, or are they corresponding? By the way it looks, okay, hopefully you guys are saying that these are alternate interior angles. And we know that alternate interior angles are going to be congruent. So we can say that 2x plus 40 will equal to 290 minus 3x. And because of this, we can then bring all the x's to one side. If I add 3x to both sides, I'll end up with 5x. And if I subtract both sides by 40, I'll end up with 250. And dividing by 5, I'll end up with 50. X is equal to 50. So if x is equal to 50, then immediately I know that this angle over here is going to be 140. And if I know this is 140, this must be 40 because it's supplementary. This must be 40. This must be 40. And then similarly, this angle over here is also 140. This is 40. This is 140. And this is 40. There you go. All right. So now you're given, again, this symbol right here. Again, I did not show that before, but this is an alternate kind of notation. Math is all about notation. It is all about communication. You mean exactly what you say, and you say exactly what you mean. So here we have a pair, that symbol there indicates that two lines are parallel. I am telling you that L1 is parallel to L2. And because L1 is parallel to L2 and L3 is our transversal because it cuts through L1 and L2, we then recognize that these angles over here are something, right? Pause the video, see if you can figure this out on your own. And when we get back, we'll go through it together. Hopefully by now you were able to figure things out on your own and you were able to recognize that these two angles shown are actually alternate exterior angles. They're on either side of the transversal, and we recognize that alternate exterior angles are indeed congruent. So then we can say 60 minus 3x is in fact the same as 7x plus 20. We can solve for the unknown here by bringing all x's to one side. I'm going to add 3x to both sides so I don't end up with negative x's. So I have 10x. I'm going to subtract 20 from both sides, so I'll end up with 40. Divide both sides by 10. I'll end up with x is equal to 4. So if I substitute 4 back in, I'm going to end up with this guy here equaling to 48. And I know that this angle over here must also be 48. The angle on the other side there must be 132 because linear pairs are supplementary. This is 132. And I can just pretty much just fill this in, recognizing that all of these are corresponding angles. So all of these are 132 and 48. All right, let's take a look at another example here. Now I'm altering the notation here a little bit. So I recognize that L1 is parallel to L2, and L3 once again is cutting through those two parallel lines. And pause the video, see if you can figure this out on your own. So welcome back. I hope you guys figured out that these two angles are in fact going to be corresponding. So corresponding angles. What do we know about corresponding angles? Corresponding angles are indeed going to be congruent. So we can say that 2 times 50 minus x will equal to 5 times x minus 2 plus 40. And again, this goes from a geometry problem and transitioning into a more algebraic kind of problem. So we're going to go through, apply our algebraic understanding. We're going to distribute. This is 100 minus 2x. The right-hand side is 5x minus 10 plus 40. We're going to combine all like terms together. We're going to bring over the 2x to the other side. I end up with 7x. The negative 10 plus 40 there is plus 30. And I have 100 is equal to 7x plus 30. I'm going to subtract over the 30 on the other side. So I end up with 70 is equal to 7x. Divide both sides by 70. I end up with x is equal to 7. So now I need to go back in and I need to figure out what all those angles are. So if I substitute what x is in there, I'm going to end up with 2 times 50 minus 7. Well, 50 minus 7 is 43. If I double that, this angle will be 86. All right, so if that's 86, then that means this side over here on the other side, the other angle must be 94. This side must be 86, this is 94, and all these are corresponding. So this is 86 and 94, 94 and 86. I'm sorry, I think I made a computational error. Did I say that it was 7? I meant that this was 10. So I made a slight error. That should say 10 there. Okay, so if that's 10, so if x is 10, then you should end up with these answers here. 80, 100, and 100. Okay? All right. So that's it. See you in the next video.